Okay, very good afternoon to everyone. I hope you are having a good time at the Data and AI Summit. Now, thank you for joining this session. Today, we will be exploring how Adobe is harnessing Agentic AI to leverage its data supply chain, and that's done by augmenting and automating its data delivery lifecycle. And that's done through some intelligent and autonomous flows. So we'll talk more about that. But firstly, we'll discuss about the key drivers and the vision and the key components of AI-based data delivery. And we'll take a reference use case, which is relevant from an Adobe perspective. We'll do a walkthrough of it, just with an intent to demonstrate that how these agents work in action. Then we'll take a brief look at the underlying architecture which supports it, as well as the business value and the benefits which has been delivered following an AI-based approach. And then we'll do a wrap-up with a quick Q&A. So we have a lot to cover. Let's dive in. So before we dwell any further, let's revisit the concept of data supply chain. You guys will be definitely familiar with it. So it's the end-to-end journey of data from raw sources to actionable insights. Now, why does it really matter? As the physical supply chain fuels commerce, the data supply chain fuels the key decision-making and the AI which runs within an organization. Now, some of its core stages are finding and capturing the data, shaping the data up just by ensuring that quality and compliance has been built in, and then delivering the insights at scale. And all the learnings what we have from a consumption perspective are incorporated back to the upstream. The whole intent is to improve the data supply chain iteratively. Now, before we talk about the agentic AI role in transforming the data supply chain, let's have a look at the underlying drivers and motivations for leaning towards an AI-based approach. The first and most important is the speed for insight and agility. Now, every day, business is evolving and getting more and more complex. So what we have heard from our business teams is that they need insights not just in days or weeks, but within minutes. Now, the next important aspect is the overall engineering efficiency and the operational toil which is involved. As you would have observed, that majority of the engineering efforts goes in terms of figuring out where the data is organized or how it is organized, and doing some repetitive, low-value data engineering and maintenance operations. The other critical factor is the end-to-end observability, lineage, and governance. Now, as data footprint and its consumption grows, I think the visibility into data assets in terms of its usage, flow, and quality becomes more critical. Last not the least is the scalability via domain-aware intelligence. Now, centralized analytics team are finding it hard to scale to support diverse business domains and to meet their unique and high-paced data needs. So with this as a background and the context, let's jump onto the agentic AI approach. Now, agentic AI is reimagining the data supply chain by bringing in the autonomy and intelligence at every phase of data supply chain. And that's been done by firstly augmenting the human decisions and tasks with intelligent recommendations, and then automating the repetitive operations across the lifecycle. Now, some of the key elements to that vision is firstly the autonomous data agents. Now, these are the agents which are smart, intelligent co-pilots, which are actually driven by a domain and a technical context, and they automate the whole 9 yards, starting from data discovery, transformation, quality, and delivery. The next critical aspect is the end-to-end orchestration of these agents. Now, AI coordinates the full data supply chain from ingestion to insights. Now, that's been done by curating the context first, and then enhancing it before propagating it to the next set of agent who is responsible for the downstream task and operations. And we'll see more of that in action. The other key element is the continuous optimizations. Now, these AI agents cannot work in isolation. So it's a human-in-loop concept. So we have designed these agents in a way that they are more adaptable to suggested improvements through additional prompting and all. Now, the trust and governance by design needs to be baked in. And I think the built-in observability, lineage tracking, and security ensures that we have a very compliant and high-quality data product coming out of as a final output from the data supply chain. Last is the self-service empowered teams. Now, business user interacts with these co-pilots to create, manage, consume the data products without having a need of understanding the technical and the functional landscape which is underneath. Now, what I'll do is I'll take a real-life use case from Adobe's enterprise and data analytics team, where the goal is to enable a timely business insight. Now, before I go into specific details, I just want to comment on the overall landscape what we have. The data landscape within Adobe is highly heterogeneous and complex, and spanning multiple business applications, platforms, technologies, and teams. Now, as you could see from the overall chart which has been outlined, requirement grooming is a big bottleneck. A significant portion of our time goes in translating the business needs or requirements to functional specifications. And that is primarily due to the fact that we have a vast data footprint. And there's a lot of tribal knowledge involved, and there is a heavy dependency on subject matter experts, what we have got. And to add more further to it, it's the lack of semantic understanding, which makes it more complex. The next stage, what you are looking at, is more of impact analysis. That is equally tedious, because data is really fragmented, and that has to flow through multiple applications or platforms. So identifying a downstream impact is manual and time-consuming. Now, rest of the phases, what you could see, whether it is planning, development, testing, they take their own sweet time. That is primarily because each of these phases is siloed, and it is very, very domain-specific, which needs, I would say, a deep technical skills and functional understanding. Now, that leads to a lot of inefficiencies and errors. Now, what we have seen is that to add more complexity to it, we are dealing with a lot of legacy code. And since we have multiple platforms, each platform has its own programming language and construct to deal with. Now, looking at all of these challenges, enter Agentic AI. Now, reimagining this, that if there are intelligent agents which are powered by the knowledge graphs, what we have built inside, they could really understand the semantics and the context. They can really assist in doing the impact analysis. They can exactly recommend what code change needs to be done and where, along with the test cases which needs to be executed. And the entire automation is done from these agents so that all the stages and phases of the life cycle could be coordinated. So with that, I'll just play a small video which is demoing the solution what we have built so that we can see how these agents work in action. So what you have on the screen is the solution or the framework what we have built. Now, the targeted persona is the analytics engineer. They will come in with a pre-curated business requirement, which is at a super high level. They will punch that into the solution, and the first agent, which is a requirement grooming agent, will come into play. They will try to understand the intent and get it a confirmation. So once that's being done, it will prompt that what kind of platforms needs to be considered in scope before that gets converted into the functional specs. Once that has been confirmed by the end user, it will just throw a set of key assets which might be relevant for the business requirement in hand. So once that's reviewed and okayed by the analyst, it will quickly turn all of that into a well-defined functional specs. Now, it will have the functional context, the key assets which are impacted, and the platform and the actions which needs to be done. Now the control is passed on to the impact analysis agent. So it will just anchor around the key asset what user has confirmed, and it will put that onto a canvas so that the entire data supply chain could be envisioned in one shot. So for that to be happen, we need to understand the entire lineage of it. So a user can go in and do a forward and a backward propagation to understand that how this asset is getting sourced and how it is exactly getting consumed. So in this case, you are seeing a stored procedure, which is relevant for the requirement, is getting fed from different tables or views, which is spanning across multiple platforms. And that is getting, I would say, pushed and consumed by Power BI or multiple views. User can actually look out for a key business terms to search within this entire graph to get the AI agent to recommend that what assets are of interest and needs to be actioned upon. So once that has been reviewed and studied, that's the screen what you're seeing on the screen, analyst is able to understand the task which will be involved, and once it is marked, he will submit this to the next agent, which is a planning agent, which will take all of this metadata and context and now convert that into a fully defined, formalized work breakdown structure. Now, this is exactly the build plan, which involves 3 code retrofitting changes and the regression testing which is needed. Now, it specifies that what kind of change is there, as well as it will do the complexity calculation and automatically log the JIRA. And analysts can now assign it to a particular engineer and the reviewer, and the mail will be directly gone to them. They'll take this task, log in back to the solution, and start doing the code changes. Good part is that they don't have to do it on their own. The next agent will suggest exactly how that needs to be done. So once the control goes to the next agent, which is a code builder in this case, it will figure out that what code objects or constructs needs to be further retrofitted. And it will give a provision for the engineer who hasn't seen that code before to really understand it. You can pick and choose any construct. It will summarize. It will help you in figuring out that how code is really organized. And the good part is, based on the functional specs which has been curated, it will be able to specify what code lines needs to be added and exactly where it needs to be injected. You can further iterate on this, ask more questions in case you are not convinced with the output. And once that's done, it will inject the code and get it ready for the deployment. Before that, the next code agent, the next agent, which is the code review agent, will come into play. They will ensure that whatever changes have been done, those are in line with the functional requirement which was laid out. And then, since we are dealing with a lot of legacy code, it will ensure that it is giving the suggestions for further application optimization and fine-tuning. So once that is reviewed and accepted, you can see a code difference in terms of what is getting changed. Now, once that's done, the next agent, which is a deployment agent, will take all of that information, ask in what all platforms this code needs to be deployed, and will ask for relevant information from a release management process. Once that is all fed in, it will go ahead and deploy the code and make a git commit. Now, that will bring into the last agent into the action, which is a validation agent. Based on the requirement in hand and the kind of code changes we have done, it will suggest what kind of test cases should be taken up from both regression and functional perspective. We can review those test cases, and in case we are OK with the recommendations being given, we can put that and add that onto our test suites. And we can then manually add more test cases or ask the AI assistant to suggest more. So once that's been done, I just need to configure the environment against which my test cases needs to be running, both source and target. And once that has been completely done, the test cases are executed and a report in an email will be sent to it. So that's how I think, with the different agents being orchestrated across the entire life cycle with human in loop just for the purpose of review, we will be able to complete the entire I'll say the data supply chain work, which was earlier spanning for days or weeks. I'll just switch back to the slide mode. Now, seeing that demo, Let's have a look at the underlying architecture which really supports it. Now, I will not go into specific technical details, as you could see that there are a lot of agents supported by knowledge graph which is making all of this happen. I'll just talk about some of the salient features which needs to be called out. The first one is the composable and extendable modular AI agents that are plugged into the various stages of data delivery lifecycle, which is making it happen. Now, let's say your data supply chain needs an agent for data quality, for data governance. All of that could also be done. We just need one more agent which can talk to any specific LLM of choice, which is fine-tuned for that operation, specify what all actions needs to be done, and then plug that in. And the overall service layer, which really orchestrates the entire coordination of agents, will be able to pick it up. And based on the intent, it will be able to route it to that agent. The next is the event-driven architecture for coordinating and orchestrating these agents. This is critical because I could just straight away go to the validation step. I may not have to make any changes. It's an upstream system impact which needs to be mitigated by just doing a regression testing. So the supervisor is playing a critical role in terms of figuring out what agent will come into play and what actions needs to be done. The other critical aspect is the contextual memory and the propagation. So these agents maintain the awareness and enhance it further with the previous user actions, their preferences, and the domain semantics. That makes each agent work effectively. Now, the other part is the interactive improvement through prompting. As you would have seen that at every agent in play, we have given a provision for end user to review the output, suggest more to it, so that we are just not completely blindly relying on the underlying agent. Lastly, I would say it's a baked-in security and compliance. So we'll see more of it. Now, Databricks is one of our key data platform, and we have leveraged a lot of their components to really build this agentic framework for the data delivery lifecycle augmentation and automation. Now, the first thing I'll call out is the Databricks Lakehouse architecture. That has really enabled us to go for a scalable orchestration of AI agents across end-to-end data supply chain. Other critical aspect is the Unity catalog. That helps us to give the right foundation of the knowledge graph by feeding in a lot of critical insights in terms of how different assets are linked to each other, what is their lineage, as well as what are their governance policies and user interaction. Then we use multiple LLM models, open source models. The use case, what you have seen, we are using Llama 3 as well as GPT-4. Now, Databricks provides a native support to host some of these large language models and then use it within our agents. We are also extensively using Databricks VectorDB, and that helps us to, I would say, perform the high-dimensional semantic search, retrieve the relevant context, as well as maintain the long-term memory across the interactions, which is needed. Lastly, I would say the governed autonomy with built-in observability. So Databricks ensures that the agents are behaving in a responsible way. And that is enforced through the access controls, audit logging, and different quality checks which Databricks provides. Now, let's look at what kind of business value we have realized so far. Now, the impact is seen on two planes. One is strategic, other one is more of operational. So it can all be related back to the underlying drivers and motivation, what I just talked about. So the first one is the accelerated time to insight. Now, AI agent-based data supply chain really shrink the data delivery from weeks to hours, enabling a faster data-driven decision making. Next is the data democratization. Now, here we empower the domain users through the self-service experiences what we have built, and that reduces the dependency on us as a central engineering group. We have also fueled the scalable innovation following this AI-based approach, because a lot of reusable components and autonomous agents allow rapid experimentation by business teams spanning across multiple domains and geographies. On the operational plane, we have seen a significant engineering productivity gain, almost like 30 to 40% to start with, for the manual task via agent-led automation. The overall output of insights which is coming in following this approach is higher in terms of quality and confidence, because we have reduced the scope for the manual-led errors. Lastly, I would say a cost optimization. Since now we have freed up our SME capacity to do higher order work, we are more efficient in our resource utilization. And the code agent, what you have seen in action, that really helps us to optimize our legacy code, making it more performant and cost-effective in terms of compute. So these are the benefits what we have seen so far. I would sum it up more onto this, that Agentic AI is more of a force multiplier for us, because it brings the continuous learning, self-orchestration, as well as intelligent orchestration and automation across the data delivery lifecycle. That was my last slide. Open for any questions.